Hi, I am Ricard, CTO at Earth Rover. At Earth Rover, we are using deep tech to help farming become more sustainable and more productive. We are tackling a big problem, which is controlling weeds without using herbicides. Okay, the world wants to become more sustainable. Herbicides, it's a big problem. The European Union has the objective to reduce herbicides 50%, and we are talking about 30 billion global market, which will be reducing and being substituted with other solutions. Weeds is a nightmare for the farmer when not being able to use herbicides. You need to use several techniques, but the old one was to do it manually. Okay. For instance, a reference customer of us, Polybel, they expend 10% of their sales on this process, on this activity. Now, as I said, doing it by hand, it's the old way. It costs 700 euros per hectare minimum. I have seen worse figures. Now, the state-of-the-art technology, it's mechanical weeding, robotic mechanical weeding mounted on tractors, and this has a cost of 362 euros per hectare, and this including all the production factors. And then there are emerging technologies like robotic, fully autonomous mechanical weeders, not mounted on tractors, but with rovers that work in a completely autonomous way. And then other technologies like lasers. Okay. And the main problem of mechanical weeding, as we will see in that video, is it damages crops. Okay, and it damages soil. The soil loses carbon, which is retained. The soil loses moisture. The crop roots are damaged, and then the farmer loses from a 3 to a 5% of its crop. So it's a reduction of yield, which is very important. Now I am introducing here our solution, which is a technology that we call LightWeeder, because we are using concentrated focused light to kill each individual weed. We use artificial intelligence and stereoscopic cameras to detect each individual weed and kill this individual weed with a flash of concentrated light. Okay, it's a very sustainable solution using solar panels, using batteries, very lightweight solution, and it has the characteristic of killing all the weeds if necessary. Okay, while other solutions always leave some weeds non-killed. Here we will see our current state of development. It's a test done in November this year in our lab. You will see how fast it is. Okay, so this technology can kill each box 20 weeds per second, and that rover you have seen has 6 modules, and therefore can kill 60 weeds per second. And it's a completely modular system, so it could be mounted on a larger machine, and we could have a higher productivity if necessary. Now you see the results here. Let's say one of the good things is that because you don't disturb the soil, you don't promote new weeds, so you can elongate the frequency with which you do this activity. So you see here on the left the area that will be weeded, and on the right the area that is the contrary that is not weeded. And you see the result after 22 days. So you see how effective is the technology. And at the same time, it's effective and it's very respectful with the environment, with animals that can be there, and with the crop particularly.
Have you used it every day or only once and then 22 days waited?
Exactly, once and then 22 days later. And then here you see that because we have all this technology on board, all these cameras and computing power, besides weeding, which is the main pain, we also provide very, very detailed data on the crop and on the weed. So you see here in the video how the machine, as it travels, it will capture each individual plant position and the volume of the plant, and we are creating on the go a very detailed map of the crop. So we introduce big data in farming. And the business model is to sell each machine for 80,000 with a 65% margin. Let's say it's not expensive, but actually our technology is very competitive, and it allows us to have this very big margin. And we have to take into account that in Europe, farmers, to invest in this kind of technology, they get 40% of grants. So they get 40% off. So it's really a very good deal for them. And apart from this initial sale, we have a yearly fee of 16,000 per machine to cover data services and maintenance services. Okay, the data that we capture, we upload it to the cloud, and we offer it as in a data warehouse to the farmer with a subscription model. And the margin on this operation is 80%. Now, comparing the cost that we achieve with the current state-of-the-art technology, the current state-of-the-art is 362. With this pricing and these fees, the cost for the customer with our technology is 230 per hectare. So it's significantly cheaper. But besides solving besides solving the problem, we don't kill 5% of the crop. So we increase the yields. So there is a very clear additional benefit. And besides this, we provide very detailed data that can be converted into money. This has been possible thanks to a multidisciplinary team, which is based in Barcelona. Basically, all the research and development is doing here. And then we also have people in England. You see here the structure of our shareholding, founders, employees, and some initial investors. And then you see here how we want to first focus on Spain and the UK, and then move to the rest of Europe and the States. And our ask is for 2 million. Sorry, because I'm running out of time. Thanks a lot. Any questions?
How can you save that no one copy your machine and bring it cheaper on the market?
The question is, how can we avoid that somebody copies?
Just
well, we have
copy.
on the technology, we have a patent. Okay, so the patent is patent pending. We registered the patent application in November last year. So in 1 year we will have the granting of the patent. And besides this, there is a lot of software and therefore this is not possible to copy.
For which markets the patent?
Sorry?
For which markets? For which countries?
The patent.
The patent worldwide, of course. Let's say we made the initial application, then we have moved to the PCT stage. So we are in the PCT phase, and we have time to decide in which markets we will apply for the national phase. But in principle, we will apply for the national phase in Europe and the United States, maybe Australia. Okay, but there is plenty of time to finish this decision.
What's the reaction of the farmers? Talking to them about the concept. I mean, the one thing is the numbers, but the other thing is when you approach them and they see this and compare it to the traditional solutions, do they think it works?
They are enthusiastic. Let's say they are really waiting for something like this. They need solutions. They don't mind adopting technology. Of course, this is a very advanced technology. They need to adopt rovers working autonomously in the field. But we are targeting the largest companies. Okay, so we are in contact with I would say 3 main companies in England and in Spain with working on sustainable or organic agriculture, and we have started pilots with them at the moment, non-paid, but then we will start with paid pilots in January. And these are early adopting companies. Let's say the big companies in agriculture, the larger companies are the early adopters of technology because they have people who can understand better these things. And then our strategy is to start with key accounts. And then when these key accounts adopt our solutions, then we will expand to smaller customers. Say. Sorry, I think, yeah.
The autonomous rover might have a problem when it's on the field. I do use at home Husqvarna. I have 4 of them that are used basically to make my garden life easier. And the nightmare is I don't need a gardener. I need someone that is every morning taking care of the Husqvarna machines because it's standing anywhere in the garden. Because there was some kind of change in the ground by an animal or something like that, and these things stop. So why was your decision not to make it as a pull one and make it just bigger? If I think about America, about the fields that they have, they're so big. And so this small thing there, they might laugh about it if they see it. And why is it not 10 meters wide and pulled behind a big truck that they normally use?
Well, because that's not so sustainable, first of all. Okay, so we are looking at having a zero carbon footprint solution.
Okay.
Zero carbon footprint. So this is part of a strategy in which we need to rely on lightweight electrical vehicles rather than very, very heavy machines. A tractor must be very heavy because a tractor is basically designed to do tilling work. And tilling means dragging the ground. That consumes huge amounts of energy. Well, we just need a vehicle to go above the ground, not touching the ground, with concentrated light. We are using a very efficient conversion of power into light and then on thermal power. You know, so it's foundational to avoid this kind of very heavy machinery. And besides this is the way to be able to always operate. For instance, one problem they have with this tractor-mounted weeding machinery is they cannot use it when it's raining. When you have a very wet field in England, the tractor compresses the soil, the tractor destroys the crop.
Yeah.
So you are not allowed to put the tractor in the field. You cannot weed.
But how big is your battery?
Sorry?
How big is your battery?
As much as necessary, but the one we are using, it allows 8 hours autonomy. And it's 10 kilowatt hours, just 10 kilowatt hours.
With the laser operating or just driving?
Sorry?
With the laser in operation or just driving 8 hours?
It's 8 hours all the operation. Let's say it's 8 hours weeding all the time. Let's say,
How much
and doing
hectare
the
you can-
maneuvers, but we're working on very large fields. For instance, in England, the farm in which we are working, it has 2,000 hectares. So it's a very, very large farm.
How much hectare you can do in the running time of the 8 hours?
With this machine, it can do 3 hectares per day. 3 hectares per day. The thing is that the machine is not very expensive. The farmer, if necessary, could have several machines working in parallel. They are autonomous. Okay, so it's really a big change
Well,
for
how is the
farming.
autonomous happening? You don't have wires around the field, I think,
No.
so is it by GPS or how do you?
It's basically a high accuracy GPS combined with computer vision and lidars and other techniques. But basically, in the farm, GPS is already very it's introduced. It's a technique which is already accepted. Some people, the tractors drive standalone. Let's say that's quite normal. So it's an environment in which you can use a kind of GPS which delivers 1 centimeter accuracy. So then it's really not very, very difficult. It's not like driving a car in the city, you know. It's very, very, of course, much easier.
Since you only had 2 seconds to have a look at it, could you go back to the second but last slide?
The second,
No, just no,
one?
the next one.
this one.
Yeah.
Yeah, well, we already have, let's say, invested 1.6 million in the technology. It's a really deep tech company. As you see, it's not just software; it's also hardware. So, and then we got support from the from the UK government. We got support from the European Union. Unfortunately, it's not here, but we have been in the EIT Food Acceleration Network program. We have a contract with the European Space Agency. Well, actually, we are now on the second contract. And then Polybel is this big organic farm which actually invested in us. Okay, so Polybel is one of the shareholders. Then now we are looking. We need 2.5 million to bring this product to market. Next year is about validation. Let's say the product is developed, but this in 2022 we need to make have the pilots and do external validation with agronomic institutions, basically, and with the universities. So there is a lot of work. So to 2022, it will be about validation and dissemination, and then in 2023, we expect to be.
What's the evaluation?
The valuation is for 8 million. Okay, so that's for 25% of the capital post money.
The 2 million or the 2.5?
2 million for 25% of the company. I mean, and let's say we are investing this year 2.5 million, but we already secured 500,000 in grants. So we only need 2 million.
Where will you do the production of the machines?
Sorry?
Where will you do the production of the robots? We have a plan to do the
It's
production.
not yet decided. It's a very high value product, not a very large volume.
Because
product,
if you
okay?
will sell a lot of them, you need production.
Let's say it will go step by step. We are not going to go to all the world at the beginning.
When you start only in
We will
Spain,
start just Spain and UK.
what you think a normal for the fields, when you say you have in England one with 300 hectare, how many machines does he need? Because you have the timetable where the plants grow, and you have to go to the plants.
I give you an example. We have a customer who it's a very big lettuce farmer, a big name, and they plant 6 hectares per day. Okay, so we need a productivity of 6 hectares per day.
So 2 rovers.
So we need 2 rovers, and this is a very large farm. Okay.
What is your biggest risk? What holds you up at night? You about this business, and what do you see? Hey,
As a risk.
Yeah, the biggest risk for you.
First of all, I'm the CTO. I'm not the CEO. So sorry because he couldn't come. He's been due to these COVID complications. Well, to be honest, I would prefer maybe if you send me your details to ask my because I would give you my personal opinion more than a strategic opinion.
It's okay, personal opinion.
But
So technically, he has no nightmares. Technically, the thing is working as it looks like.
my personal opinion, because I'm the CTO and I see more the technical side, is I think we have the best solution available. Really, my opinion is that maybe somebody comes with another solution, but so long if there is no new alternative technology, I think that on that side there is no risk.
It's about competition and being.
There is really we have beaten the competition. To give you an idea, there is a company working on laser reading from America, Carbon Robotics. I don't know if anybody has heard, but if you are not in the sector, it's difficult. But Carbon Robotics are targeting the same market, and our solution is much better than them. But they are older, so they have 2 years in advance to us, and now they are in production. They have raised 27 million for acceleration. Okay? We cannot now raise a Series A because we need to finalize the development. But by the end of next year, we will be raising a Series A.